Have you ever asked yourself, where did everything come from? How did our universe originate? These questions have sparked curiosity for centuries, leading to countless theories and debates. Some suggest a divine architect, others propose infinite cycles of expansion and contraction, while others still ponder the role of quantum fluctuations. However, among the sea of ideas, one theory stands tall, dominating the scientific consensus. It's the Big Bang theory, a notion that our universe in all its vastness started from an infinitely small, infinitely hot and infinitely dense point. This point, or singularity, exploded and has been expanding ever since, giving birth to galaxies, stars, planets, and everything we know and see. The Big Bang theory is not just a wild guess or a fanciful tale. It's a theory built upon decades of scientific observation and mathematical computation. So journey with me as we delve into the Big Bang theory, the most widely accepted explanation for the universe's origins. Imagine everything you know, every star, every galaxy, every atom, compressed into an infinitesimally small, dense, and hot point. This is what we call the singularity. The singularity, as we understand it, is a concept that pushes the boundaries of our comprehension. It is a point where all the laws of physics as we know them break down. It's a state where space and time become so warped, they cease to exist in the ways we understand. In the singularity, everything that will ever exist in our universe is crunched into a space so small it effectively has no size. Now let's talk about density. When we say the singularity was incredibly dense, we're not talking about a few extra kilograms squeezed into a small space. No, we're talking about the whole universe. Every ounce of matter, every photon of light, packed into a point so small, it's almost inconceivable. It was also incredibly hot. We're not talking about a summer day in the outback hot. We're talking about temperatures so high, they make the heart of the sun seem like a chilly winter morning. We're talking about heat so intense atoms themselves couldn't exist. And yet, from this point of infinite heat and density, something happened. A change, an expansion, but not an explosion. This isn't a bomb going off. This is every piece of matter, every bit of energy spreading out, creating space as it goes. This singularity, this point of infinite density and heat, wasn't just the birthplace of matter and energy. It was the birthplace of time itself. Before the singularity, there was no before. Time, as we understand it, didn't exist. The singularity was a point, and from that point time began to flow and space began to expand. So when we talk about the universe, we're not just talking about stars and galaxies. We're talking about the birth of space, the birth of time, the birth of everything we know. This singularity, this point of infinite density, is where our story begins. Then, in a flash, the singularity exploded. This is the moment we call the Big Bang. The term Big Bang is somewhat of a misnomer. It wasn't an explosion in the traditional sense, but rather an incredibly rapid expansion of space itself. Picture an infinite, hot, and incredibly dense point of energy, smaller than a single atom. Then, for reasons that remain a mystery even today, this singularity began to expand. In an infinitesimal fraction of a second, the universe grew exponentially, an event we refer to as cosmic inflation. This was not just the spreading out of matter and energy, but the creation of space itself. As it expanded, the universe cooled, and the fundamental forces of nature that we are familiar with, gravity, electromagnetism, and the strong and weak nuclear forces, began to take shape. Following this period of inflation, the universe was a hot, dense sea of energy and matter. It was so hot, in fact, that particles of matter and antimatter were continually being created and annihilated. However, for reasons that are still not fully understood, matter slightly outnumbered antimatter. This tiny imbalance was crucial. As the universe cooled further, the annihilation of matter and antimatter slowed, leaving behind a small excess of matter. This remaining matter is what forms everything we see in the universe today. It's vital to remember that all of this happened in less than a blink of an eye. A fraction of a second after the Big Bang, the universe was already 1,000,000 billion kilometers across and cooling rapidly. It was a place of unimaginable heat and energy, but it was also the birthplace of matter, of stars, of galaxies, and ultimately of life itself. As the universe continued to expand and cool, the the first atoms began to form, and the cosmic stage was set for the next act in the story of our universe. From this violent explosion, the universe as we know it began to take shape. The universe didn't just stop after the Big Bang. It continued, and still continues, to evolve. Imagine a vast cosmic soup, a hot, dense sea of particles and energy. This was our universe shortly after the Big Bang. But as time went on, this cosmic soup began to cool, and as it did, something wondrous happened. The particles began to combine, forming the first atoms. Mostly hydrogen and helium, these atoms were the building blocks of everything we know today. With the formation of atoms, the universe was no longer a foggy, opaque soup. It became transparent, and light could travel freely for the first time. This is the cosmic background radiation we still detect today, a relic of our universe's infancy. But the story didn't stop there. These atoms began to clump together, pulled by the irresistible force of gravity. Over hundreds of millions of years, these clumps grew larger and denser, eventually igniting to form the first stars. These stars were nothing like the ones we see today. They were massive, burning hot and bright, and their lives were violent and short. And yet, their deaths were not in vain. In their final moments, these first stars released heavier elements into the universe, elements like carbon and oxygen, the building blocks of life as we know it. Around these stars, galaxies began to form, vast islands of stars held together by gravity. Some galaxies were small, with just a few billion stars. Others were massive, with trillions of stars. Each one was a universe unto itself, a testament to the incredible power of gravity and time. And so, over billions of years, our universe evolved from a hot, dense point into a vast, complex cosmos filled with galaxies, stars, planets, and life. So, from a single point, the universe has grown into the vast cosmos we see today. Fast forward to today, about 13.8 billion years after the Big Bang. Our universe, a cosmic tapestry of galaxies, stars, and planets, is in the prime of its life. It's a bustling hub of activity, with stars being born and dying, galaxies colliding and merging, and planets hosting the potential for life. The universe is not just sitting idle, it's expanding. This expansion, discovered by Edwin Hubble in the early 20th century, is happening at an accelerated pace. Dark energy, a mysterious force we're yet to fully understand, appears to be the driver behind this acceleration. Our universe today is a place of wonder and mystery, with black holes bending the fabric of space-time, neutron stars spinning at unimaginable speeds, and galaxies full of stars waiting to be discovered. It's a testament to the incredible journey that started with a singularity, a point of infinite density and heat. Looking ahead, the future of the universe is as fascinating as its past. One theory, known as the Big Freeze, suggests that as the universe continues to expand, it will eventually become too sparse to support the formation of new stars. In this scenario, the universe will gradually cool and fade into darkness over trillions of years. Another theory, the Big Crunch, proposes that the universe's expansion might one day reverse, leading to a gravitational collapse. In this scenario, everything in the universe would eventually converge into a singular point, potentially sparking another Big Bang. Yet another theory, the Big Rip, suggests that the universe could tear itself apart. The accelerated expansion would become so intense that galaxies, stars, planets, and eventually even atoms would be ripped apart. These are just theories, and the truth is, we don't know for sure what the future holds for our vast and complex universe. But one thing is certain, the universe is always changing, always evolving. It's a cosmic dance that's been going on for billions of years, and we're privileged to be a part of it. So even as we speak, the universe continues its journey, evolving and changing, just as it has for billions of years. So, we've taken a whirlwind tour of the universe, from its beginnings to its potential end. We started with the greatest mystery of all, the birth of the universe, and explored the Big Bang theory. It's a concept that took us back around 14 billion years ago, when all matter, energy, space, and even time itself began from a singular point of infinite density. We then ventured through the evolution of the universe, witnessing how it expanded and cooled, giving birth to galaxies, stars, and planets. We saw how cosmic structures, as we know them, formed and evolved into the magnificent cosmos we observe today. And we didn't stop at the present. We also dared to glimpse into the future, contemplating the potential fate of our universe, whether it will continue expanding forever or eventually collapse back into itself. Next time you look up at the night sky, remember, you're not just looking at stars. You're looking at the history of the universe written in light.